In this video, we're going to have a look at conditional probability. This is the kind of probability where the things that happened earlier impact the likelihood of things that happen later. For those who don't know me, my name is Chris Hinazoni. I've been tutoring for about 2 years now, and I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. At its core, conditional probability is all about looking at smaller sections of data. The key word to look for here is the word given. If the word given shows up in your probability question, then 9 times out of 10, that question is going to be a conditional probability question. Anyway, let's explore what conditional probability even is. We can do this most effectively by looking at a Venn diagram. In this example, we're going to track the possibilities of a dice roll. The first event that I want to keep track of is rolling a number that is greater than 3. And the second event that I'll keep track of is all of the even numbers of that dice. If we fill out a Venn diagram, we can see more clearly where all of the elements of that sample space are distributed. Now we can answer the question, which in this case is to find the probability that I rolled a number greater than 3, given that I rolled an even number. Normally, the probability of rolling a number that is greater than 3 is just going to be 3 out of 6. There are 3 numbers on the 6-sided dice which are greater than 3, and there are 6 possibilities, 3 out of 6. But in this case, we have a restriction to consider. We are only allowed to look within the even numbers because the question told us that the number rolled was even. If we look at the reduced sample space, we can see that there are only 2 numbers that are still greater than 3, out of a total of 3 possible numbers which are even, giving us a total probability of 2 out of 3. The notation for conditional probability uses a vertical line. The thing immediately to the left of that vertical line is the probability that we're looking for. In this case, it was looking for numbers greater than 3, hence that will go on the left-hand side of that vertical line. On the right-hand side is the conditional. In this case, the condition that was given to us was that we rolled an even number. Hence, that will go on the right-hand side. So in total, that statement just reads, the probability that we rolled a number greater than 3, given that that number was even. Now, you don't always have to use Venn diagrams when it comes to solving conditional probability. There is actually a formula we can use. The probability of some event A occurring, given that some other event B occurs, is always going to be given by the division of the intersection between those 2 events and the probability of the conditional on the bottom. If you look back at that Venn diagram, that's exactly what we did. The numbers that were greater than 3 was the intersection part of the Venn diagram, and when we divided, we were simply dividing by all the elements that were even. So let's try to use that conditional probability formula. In this case, we're looking at students that study different subjects. We know this is a conditional probability question because of that keyword, given. Anytime we want to find the probability of something after something else has already happened, that's conditional probability. So let's set up the equation. In this case, studying math is the thing we want to find the probability of, so it goes on the left. And the conditional is studying physics, so it's going to go on the right and in the denominator. We just need to find both terms on that right-hand side. So let's start with the intersection. We're told that 8 students study both math and physics. The keyword "and" implies an intersection between those 2 events. So to convert that to a probability, you're just going to take those 8 students that study both physics and math and divide that by the total number of students in the sample size. Next, we want to find our denominator, which in this case is the probability that someone studies physics. Well, in this case, there are 12 students who study physics, out of a total sample size of 24, giving us a probability of 12 over 24. From here, we just perform the division. Now, you'll notice that I use a division symbol here, and that's because if you just stack the fractions on top of each other, it can be kind of complicated to figure out how you handle that situation. If you instead use a division symbol, then all you've got to do is flip the fraction, turn into a multiplication, and then just cancel things down from there. It's much easier to see what's going on. The other thing I'll point out is that I didn't simplify any of the fractions before doing the arithmetic. This is because whenever you're doing these kinds of questions, the denominators will cancel out, leaving the simplification that you do much easier to do. Tree diagrams are powerful tools for visualizing conditional probability. Let's give it a shot. This question is all about the failure rates of motors that were produced on different lines of production. If we think about the sequence of events that happens here, motors are assembled on a production line and then come out of that production line either faulty or working. With that in mind, we'll start our tree diagram with the production lines and then branch off into faulty or not faulty. All we're going to do from here is fill in some of the probabilities. For us, we're told the failure rates. A 5% failure rate is going to go to the line A motors, and an 8% failure rate is going to go to the line B motors. The reason this is a conditional probability question is because the percentage failure rate depends on what production line the motor came from. In fact, tree diagrams are always conditional on what happened before. Anyway, we can find the complement probabilities of each branch by just making sure that any individual section adds up to 1. Now, we just have to figure out the probability that the motor came from line A or from line B. Now, in most cases, this is usually a 50-50. But in this case, the question has given us more information to solve this. We're told that line A produces 40 motors, and line B produces 50 motors. So, at the end of the hour, if we're picking one motor from that total, then the probability that we select one from line B is going to be 5 out of 9. And the probability of selecting one from line A is going to be 4 out of 9. So, now that we've filled out the tree diagram, we can now finally answer the question. What is the probability that our motor is faulty? Well, there are 2 paths that end in faulty motors, so we're just going to multiply along those branches and then add each path together at the end. My recommendation is that you convert your decimals into fractions before you do the arithmetic. And when you simplify things down, you'll get to a final probability of 1 out of 15. Sometimes the information that you're given will come to you in the form of a table. Usually this is the results of some sort of survey. In this case, the table is comparing the regular use of medication with age. We want to know the probability that someone is regularly using medication given that they are younger than 30. If you have a table of data like this, you have a couple of options, one of which is simply just to use the conditional probability formula like you've done before. So, first things first, we'll just write out the formula. In this case, the thing we want to find the probability of is regular use of medication, and the conditional is being younger than 30. This means that our denominator must be the probability of being younger than 30. So let's start there. Looking at the table, we can see that there are 520 total people that were younger than 30. So to convert that to a probability, all we do is divide by the total number of people that were surveyed, which in this case is 1,000. Now for the intersection. Again, if we refer back to the table, we can see that there were 200 people that both used medication and were younger than 30, out of a total 1,000. So once again, we're just going to perform that division and then simplify. Now, here's an alternative for those who are already quite confident with using that formula. If you recall back in the beginning, I said that conditional probability simply just reduces the sample size that you look at. In this case, we were looking specifically within people who are younger than 30. So if we just zoom in on that column and ignore everything else, there were 200 people that used medication out of a total of 520. And sure enough, that's the probability that we ended up with. This approach to solving these kinds of questions doesn't need a table of data either. If you go back and look at the previous questions, you'll notice that the denominator never mattered. But once again, I want to highlight, this technique should really only be used by people who are already familiar with how conditional probability works. It is a shortcut, but still, don't use it unless you've already mastered the formula. The last thing we'll look at is how conditional probability can be used to solve some of the generic probability questions. In this case, we have an array of known probabilities, and we have to figure out what the intersection is. Well, if a conditional probability is one of those known probabilities, then a good starting spot would be to expand that probability out using that conditional probability formula. From here, if we look closely, that conditional probability formula contains that intersection that we want. Remember, that intersection can be written in any order. A intersecting B is the exact same thing as B intersecting A. So let's start by plugging in the known values. In this case, we know the conditional and we know the probability of A. The only unknown left is the intersection. So we're just going to rearrange to get it on its own and simplify the answer, and there we go. So the key takeaway here is that conditional probability can be used to solve intersections as well. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool. You should check it out. I'll see you there.